Hello everyone, it's Peter. Welcome you back. This class we will move to the collection framework. Here I give a picture of the collection API in Java. Before that, I want to make up two concepts in OOP concepts. One is the final keyword. We already mentioned that a final object means that its reference cannot be changed. A final primitive type means its value cannot be changed. This is about the final variable. Now, final has two other usages called final class cannot be subclassed or cannot be extended. It means a final class cannot have a subclass. A typical example is a string is a final class, and all wrapper classes are final class. Okay. The second thing is a final method cannot be overridden. It's final method cannot be overridden. So here I can give a quick example for this. Assume we define a class final class A. And if you say class B extends A to inherit A, then this will be illegal. So it will have a compile error. So if you say A equal to new B, such kind of things, it will be, or just A equal to new A. I just loaded. Yeah. So cannot inherit from final A. Okay. That's first thing. The second thing is in the A, if I have a final method, public final void full, and in the B, if I override public void full, then this will be another error. Okay, B cannot override the full in A. The reason is that the override method is final. Okay, just make a quick proof. The second topic last time I mentioned is about the generics, because in collection framework we all use generics. So what is generic? Generic is given a type is given a class for a specific type. So I can use let me give an example. Okay, in this one I give a new package. So I moved the generic in the collection API. com.java.collection. Okay, I use this one. Let me write a new class called generic wrapper. I just give a name. So I will show you how to write a generic class. So here I use a sub-angle like this. I give a type. The type you can say A, B, C, D. Doesn't matter. I just use E. So inside I have an element. This element is a generic element. So this is a generic wrapper. I wrap any object. I can wrap any object. So in the constructor, generic wrapper, the element. So this dot element equal to element. And I can also use get and setters. I can automatically generate get and setters. And then I return a type, get type of this element. So get type I can return like element dot get class dot get name. Yeah. So this means we already mentioned about get class in the reflection, right? And get name is the class name. So I know I can wrap anything. If I wrap an integer, then it will return integer. If I wrap a string, it will return a string. Okay. So let me do a test. New package. Usually I use the same package. Okay, then a new class generic wrapper test. Okay. Now let me test get type, this method. So generic wrapper WP1 use equals to, so here I can give a type. I can use how to write it in the Java. I can say, oh, I want to wrap an integer. So WP equals to new generic wrapper. You can also write integer here. Okay, this test. They'll give an element, say 100. So in Java 7, I have to write like this, but in Java 8, I can remove this integer. So if this one is already defined type, a wrapper type, or a generic type here, then I just use an empty triangle here. But in Java 7, you have to add an integer here. Okay, this is a small difference between Java 7 and Java 8. So make things easy, and then I assertions assert equals, then it should be integer, right? WP.getType. Okay. Now let's make a test. It's java.long integer. It give the full name. Okay. Then I give the full name with the package java.long.integer. Okay. Now I can write another one. Generic wrapper string. Okay. Equals to new generic wrapper. I give a string like ABC. This is a string. So I use WP2 long.string. So it means in this generic wrapper, I use generic type with sharp angle. I can define any type in this one. Okay. Now let's run it. Okay. So this is one way. I give you another way to use get type. There's a keyword called instance of. Okay. Now I can comment this one. I can if element instance of integer. If it's instance of integer, then I return java.long.integer. Okay. Else if element instance of string, right? So then I return java.long.string. Okay. Else if I don't know, I can return unknown. I don't know the type. Okay. So instance of is another way to verify the type of the element. Then if I run this one, yeah, it's also correct. Now I talk a little bit about instance of and get class. Okay, I use this example. Let me write this. Suppose I have class A, and I have class B extends A. Okay. Now here I use A equals to new B. Now we know for this small a, and let's say b equals to, I use the downcasting, I can do this one. So I print out a dot get class dot get name. So this one should be b, right? Let's execute. It's b, right? So A's type is B because it uses new B to create the object of A. It's just use upcasting to A, then downcasting to B. And the B and A should have the same class. If I use this one, use B. Okay. It's all, both of them are B. But I use instance of is different. So we can say instance of is a boolean. A instance of A. It should be true. Yeah. A instance of B is also true. then B is instance of A is also true. B is instance of B is also true. See, it's all true. It means what? If I use instance of, if the object can do upcasting or downcasting to that type, if we say A instance of A is true, it means A can do upcasting or downcasting to this type of A, no matter upcasting or downcasting. But get class can find the exact type. Both A and B will go to the B because the generator, the constructor to build this object is B, so it's always B. But if I use instance of, it's always true, right? So it can go upcasting or downcasting. I just want to clarify the two concepts. Then now we move to the collection framework. Now we understand use sharp angle. We can write a generic type. So we have a collection. Collection is a collection of object. We have top interface. I use the circle to represent the interface. I use rectangle to represent the class. So in the collection interface, there are two sub interface called list and set. And under list, we have some concrete class called array list, vector, and linked list. This is what we used frequently. And under set, we have hash set, linked hash set, and tree set. Map. Map is different from collection. Map is a key value pairs. So collection is a collection of one object, and the map is a collection of key value pairs. That's two objects as a pair, and one is a key, one is a value. So map has some concrete class like hash map. That's most frequently used hash map, linked hash map, tree map, weak hash map, and concurrent hash map. Okay. I have some green one, which means that we frequently use in our future projects. Okay. Now, here I make up a concept of weak conference because here I talk about the weak hash map. Weak hash map means the hash map is weak. It's weak referenced. Weak reference means that after garbage collection, the object is gone. So I give an example of the weak hash map. Let's do this one. In the test, let me new class. Let's say weak hash map test. No. Because this one I used I don't use unit test because there's no unit test, so I can move this guy to the collection, to the main part, because in the test part I always use unit test. So here I use main method. So let's talk about weak hash map. The key, say I use a string as the key, I use integer as the value, as a map equals to new weak hash map. So here I don't have to use this one, I can create this one. Okay. So in the map, the method is very simple. So map.put key value as a key. I can say new string A. Why I use new string A? Last time I talked about string pool. If I use just a constant A, if I write like A, like this, so this key cannot be garbage collected because this is in the in the string pool. Okay. Now I use new string A. This is on the heap. Let's say 100. I give two value. B is 200. Now I print out the size. Size of the map. I use map.size. So the size should be 2. Okay, size of the map is 2. Now, next I use garbage collection. System.gc. Then let me run size map after gc. Okay. is still 2, but I think after you call GC, it may take some time. So I use try thread.sleep 100. That's this is a delay. Okay. See, it's 0. Okay. This proves two things. So this code is just a delay code. So we may use a lot in the future. So that doesn't matter. So two things. The first thing is when we call garbage collector, it may not run the garbage collector immediately. What I say is immediately, because it may take some time. And then after that, after garbage collection is collected, then the two keys will be garbage collected, so the size will become 0. I didn't remove anything. Okay, this is weak hash map. Now, how the map? The normal map is I can run this one. Okay. I can write a method like this. Okay. Public private static map string integer. I'm going to write another method to repeatedly do this code, but now I don't need to do that. Okay, I think I can put them together. I do another thing. Okay, I use a normal map. It's a hash map. Hash map is a normal map. It's strong referenced. I also do the same thing. Is import it. That's hash map equals to new hash map. So I can also put the same thing here, but here I can to hash map. Hash map. Put, let's say, C and D. So let's compare their difference. Size of the map is this one, and size of the hash map. So we compare the weak hash map and the normal hash map. Okay, now after collection, I can copy this code, the hash map. Now I think this one can prove about weak reference. Let's run it. See, the size of map is 2. This is weak hash map, and this is hash map is also 2. Now after garbage collection, the weak hash map, the size is 0. So all the key value pairs is gone because it's weak referenced after garbage collection is gone. And the hash map, the size is still 2. Okay, it's not garbage collected because this is a strong reference. Okay, I just want to use this example to prove what happens to the weak reference and what happens to the strong reference. Okay, now this is a very small thing. Now we come to the big thing. It's about the collection framework. We will use those APIs like list, set, release, link, solve. First, we need to compare their difference. What is the difference between list and set? Let's see. List was set. We can say list is an ordered collection, and set has no duplicates. So there are two keywords. One is called ordered, one is called duplicate. Now, ordered is an easy one. It keeps insertion order. But the set is not. They may not keep the insertion order. Okay. Now, let's make an example. To use the list and set. Because this concept is very easy, and I just do it here. Import java.util.start. All the collection is from the java.util package. You need to manually import it. For others like string, like integer, those APIs, they are in the java.lang. Java.lang is by default imported in the code. Okay, now let's say list a string. This is a list equals new array list. So this is upcasting. We know array list is a subclass of list. So here we can use list, but here we can use array list. This is fine. You can also write this as a list, as an array list. But usually we use a top level type. I just use list. This is array list. We can also use a vector or linked list. In this concept of order the collection, doesn't matter. It doesn't matter. Now I add some elements. List dot add like x. List dot add a. List dot add c. Okay, we know if we sorted it, a is the smallest one, x is the biggest one. But if I go through it, I can use string str. This is a new feature in I think it's starting from Java 5. So you don't have to use the index like I just use the column to go through a list. Okay. This is string. So I just go through the list. So you can execute it. It's XAC. It keeps insertion order. Okay. Now I do the same thing for set. Like set is a string. It's a set. Equal new hash set. Okay. I also add the 3 elements x a for string str is a set. Okay. Okay. Now let's run it. You can see it's ACX. Okay. For list, it keeps the insertion order is inserted as XAC, so it prints out XAC. But in the set, it printed as ACX. But you should not be get confused that will set be sorted? Actually, it's not. ACX is just by accident. It looks like starting from the smallest one to the biggest one. But if you have more complex strings, it's not only one character, it's many characters, it's not sorted. Set, this example just proves that set does not keep the insertion order, but the list does. List does. So this is about list and set. Now the next keyword is duplicates. Duplicates. How do you mean duplicate? We say the 2 elements are duplicate, or means the same element. They are the same. Okay. So set cannot have each element in the set is unique. Now here is the important thing. How do we identify duplicates? Suppose object A and object B. Okay. Let's see. Question: how to identify object A and object B are duplicates, or they are the same element or different element? So when we talk about the object, there are 2 concepts: is reference or value, right? Reference and value. So when you say this the same element, do you mean the same reference or do you mean the same value? So the rule is, here I give you the rule. The rule is we first compare its reference. The reference is if they are the same element. But to compare reference, because the object may have different type. Some is a string and some is integers or other types. So we use hash code to get their reference. Let's say we introduce hash code. So first I write the rule here, then I make a test to prove that the rule is a dot hash code equal to b dot hash code. If hash code is the same, that's fine. Sorry. If hash code is the same, then I compare the value a dot equals b. Basically, it's like this. First, we compare the hash code. Hash code returns the last time we talked about the reference, right? The hash code returns the integer value of the address. So they should have the same address, they should have the same value. First they check the address, then they check the value. It's first compare hash code, then compare equals. Actually, there's a small tricky one. So the real one is they also compare this one. Or that's the full description. But this is a very, very deep one. Okay. Now I use the simplified version to help you understand. Then I will talk about this later. Let's still use this formula. Hash code equal to b dot hash code, and then a dot equals b. Now let's talk about a string. Okay. Let's say string s1 equals to new string like def. String s2 equals to new string def. So you can see the two strings, they have the same value def, but they have different hash code. They have different address, but the hash code is overridden. So if I say I print out s1 dot hash code plus s2 dot hash code, so you can see they should have the same hash code. See, they are same hash code. Because string as a subclass of object, it can override hash code so that it doesn't reflect the real address. If you have object, so if I have another class A here, I have some value, say int value, then A have a constructor, this dot value equals to value. Okay, I use this one. Now, if I write A equals to new A with 100, B equals new A with 100, they have the same value inside, but they are all new. So if this time you print out A dot hash code plus B dot hash code. Okay, so let's compare the difference. The hash code anchor string literal. What's wrong? I think this. Let's change to A, change to B. Okay, should be correct. See, you can see they have different hash code. This hash code for class A, it does not override hash code, so it reflects the current address of the integer value or address of the of object A and B. Now, let me override hash code. Override int hash code. I just return this value. You can define any hash code. I just return their value. So if I execute it, so the hash code is changed. So if I define class A, I can override hash code. Of course, in Java, string is defined by Java group. They can also override hash code to make the same value has the same hash code. Okay. So if the value is def, they should have the same hash code. Okay. Now let me use a set string. The set1 equals to new hash set. Okay, set1 dot add s1, set1 dot add s2. So you can see set1 dot size. Set1 dot size. So it should be 1, right? Because s1 and s2 they have the same hash code. We just prove that. And if we use equals, s1 dot equals s2 is true, right? We print out this one. Say s1 equals s2. S1 dot equals s2. Okay, that's good. Say it's true, right? S1 is equal to S2. S2 is true. Now, for this A, I can run the same thing. If A equals to B, here I can use A dot equals to B. This is false. See, it's false. So if I run another set, let's say set of A, set 2 equals to new hash set 2 dot add A, set 2 dot add B. So now I print out size of set 2 dot size. So set 2 dot size should be 2. You can see that. So here I come back to our formula. First is we'll check hash code, then we'll check equals, right? We'll check equals. So I can add a line in the hash code. We can say print out check hash code. And so you can see that. See, check hash code, check hash code. So if we add A, they will check hash code. If we add B, it will check hash code. Like this. So if we want to get the size, if we add it, we will check. If we run it, we will check hash code. Now, the reason is now we already proved this formula. So we first compare hash code, then compare equals. Now, for A, how do I make A and B to be the same element? I also need to override equals method. Boolean equals equals this object. This is the object obj. So first it will check if obj can be downcasting to this A. If obj instance of we use this keyword of A. Okay, then I can do downcasting A another object equals to A obj. When we do downcasting, we need to use instance of. Otherwise, you do the downcasting directly, it will have a class casting exception. It will have exception. Then after that, so we can return another this dot value equal to another dot value. We compare the value inside. If it's not instance of A, else I just return false. Right? I just return false. Okay, I can use this one, override. So now let's run it. So check hash code, size of set 2 is 1. Right? So do we check equals? I also run here. Print check equals. So check hash code, then check equals, right? We really check equals. So size of set 2 is 1. Right. Now we can give a conclusion, that is to update to make duplicates in hash set work. You need to override hash code and equals method in your own class to give customized definition of duplicates. Okay, so for example, if you have two persons, the person may have first name, last name, and date of birth, DOB, date of birth. So how do you identify the two persons are the same person? You may want to have the same first name, same last name, and the same date of birth, right? So all of them are the same. Then if you define a person, you need to override hash code. Hash code can do any kind of hash code. And then the equals, you have to compare all the three fields. And the hash code, how to define hash code is another big story. When we talk about the inside structure of set, we will give a good definition and a bad definition examples of the hash code. Okay. Now, so this one we just have a start to talk about what's the meaning of the duplicates in a set. This only means the hash set. Tree set is a different story. Tree set is ordered. So tree set is sorted. Sorted means that the two elements can compare which one is bigger, which one is smaller, or they are the same. If the tree set, by comparison, they are the same, then they are the same element. That's a duplicate element. Otherwise, it's not. That's tree set. Where I just say tree set is sorted, thus it uses comparison to determine duplicates. But both tree set and hash set cannot allow duplicates in the collection. But they use different ways. We will focus more on hash set. But tree set is quite simple. Tree set is all the elements are sorted. So after sorting, so in the sorting like 1, 2, 2, 3, 2 and 2 are duplicates. They are the same. So it will be kicked out. It will be kicked out. Okay. So collection framework is big. So we will also break it into several sessions. Now I will finish in this session, and we will move next to talk about some more deeper, dive deep into the hash set and to explain the structure in the hash set. Then give the full explanation of the duplicates. Thank you.